Hi guys, and welcome back. Let's go ahead and get these components installed on our cluster, and we'll go ahead and initialize it, and then we'll join our worker nodes to it. So I'm going to be installing this version of kubeadm and the other utilities like kubectl and the kubelet. So rather than just running apt-get install on those components without specifying a version, what I'm really going to do is say apt-get install, and then we're going to say kubeadm equals the version number that we want to install, and then we're going to do the same thing for kubectl, paste in that version. Do note that there is a -00 on that package version. It's not just 1.21.4, but it also has the -00 on there as well. And then finally, we're going to specify kubelet equals that same version, and we'll just say --yes. And then we're going to go ahead and run that on our other nodes as well, because we're going to need those in order to set up these worker nodes on our cluster. So now that we've got our components installed here, we need to actually initialize the cluster. And we do that with kubeadm. And then if we take a look at the help for it, we're going to use init. And this is going to allow us to set up a new Kubernetes control plane or master node. So we'll do kubeadm init --help. And one of the options we're going to need to specify here is going to be the pod CIDR block. So that would be pod network CIDR, and that'll be the cluster internal network that we want to use. And what else we want to do is to specify the version that we're going to be setting up. So let's go ahead and run kubeadm init, and then I'll specify pod network CIDR. And I'll go ahead and just choose an IP range like 10.71.0.0/16. And let's see if there's anything else that we might want to set. We could also give it a custom DNS name here, like service DNS domain. I could call this cbtnuggets.local, for example. We want to change it from cluster.local, which is the default for internal services. And let's see what else. Do we really need to specify anything else? I don't think so. However, we could specify a Kubernetes version here, and that will basically just inform the kubeadm that we want to install a specific version. And so I think we were using, let's see, 1.21.4. So we'll go ahead and specify that here, and we'll go ahead and run this. So now you can see it says using Kubernetes 1.21.4. That version is consistent with the components that we installed on our cluster here. And so now it's going to initialize a new cluster using that historical version. Of course, you could take a look at the output from the apt-cache Madison command and use a different version here, but we went ahead and used 1.21.4. Now, once the Kubernetes cluster has been initialized, we'll need to also install a container network interface. And I'm going to go ahead and use Calico, as I often do, because it's just very easy to install on our cluster. So we're going to grab the Calico YAML file here and download it onto our master node, and then we'll just do a kubectl apply there as well. And once we've got the CNI installed, then we can go ahead and join our worker nodes into our cluster. The other thing we'll want to do is make sure that we copy our kubeconfig over, and that'll just make sure that we're able to use kubectl. Let me do kubectl version, and sure enough, you can see that we are able to connect to our server. So we've downloaded the Calico YAML file here. Let's go ahead and do the apply command here. That'll apply Calico to our new cluster here. And then just to confirm, we'll do a kubectl namespace kube system and just say get all. And we just want to kind of make sure that everything is healthy here. So we can see that core DNS has not spun up yet because of the container network interface missing. And so once the Calico has completed initialization, as you can see, it's still in the process here, then the core DNS pods should go ahead and spin up successfully. So just give Calico and core DNS a couple of minutes to spin up here, and it looks like it is just about at the point where it is running. Great. So now we've got Calico running, we've got Core DNS running, and it looks like our cluster is in a relatively healthy state here. So now we can go ahead and add in our worker nodes into our cluster. If we do kubectl get node, you'll see that the only node we currently have is master01, and it's running 1.21.4. So now let's join our other nodes into the cluster. And if we scroll up a little bit here back to where kubeadm completed, let's find that here. So here's our join command. We can join worker nodes to our cluster by using this command right here. And that'll just join it into the API server IP address here with this token, and then it will automatically discover the CA cert hash. So it's a very straightforward process in order to join our worker nodes. So we'll run that on both of these machines, and then we'll make sure that the master node is able to identify both of those worker nodes. So let's do kubectl get node again, and it'll take just a few seconds for both of these workers to come online. They don't initialize immediately, but it probably takes, less than 30 seconds for them to initialize. And sure enough, worker 1 is online there in 21 seconds, and node number 2 in 22 seconds is also online. So now we have a fully functioning cluster here running version 1.21.4. So let's actually spin up a workload onto this cluster so that we could simulate having a production cluster with some kind of pods running on it. And I'm just going to use Nginx because it's really easy. We don't have to worry about setting up any extra dependencies. So what I'm going to do is actually create a deployment controller. So let's do a kubectl create, and we're going to create a deployment controller, and we'll just spin up a few replicas of a Nginx pod. So we're going to do kubectl create deployment and say image equals Nginx. And what we're going to do is give it a name. So I'm going to call it my Nginx deployment, and that should go ahead and create it. Now I can go ahead and scale that up as well. So if I do a kubectl get all, you can see that by default here, it's just created a single pod as part of the replica set that the deployment controller created. So what I'm going to do is actually scale the deployment controller up to maybe run, let's say 4 pods, just so we have a few different pods running. Let's do kubectl scale and say deployment / my Nginx deployment. And then we'll specify replicas. Replicas equals, how about 4? And now it says scaled, so we'll just come back and do a get all again. And after a few seconds here, we should have 4 Nginx pods running. And these should be distributed across the 2 different nodes, the worker nodes that we have in our cluster. I don't think that any of them are going to get scheduled on our master node because the master node has a taint that prevents pods from getting scheduled on it. Because the master nodes really should not be running your actual production applications. The master nodes should purely be there in order for you to manage your cluster and actually get pods scheduled out onto the worker nodes. So if we do a kubectl describe pod, let's do describe pod. That's going to print out all of the pod details for the entire cluster. And so what we're going to look for on each of these pods is just to make sure that the pods have been scheduled on the worker nodes. And right here, you can see that this pod was scheduled on worker 02. And then we'll find the next one, and that is also on worker 02. And we'll keep going up, and we have one on worker 01. And the last one is also on worker 01. So basically we have 2 pods for our Nginx deployment running on each of the 2 workers. So 2 on worker 01 and 2 on worker 02. So now that we've got 2 different worker nodes in the cluster, we can now take a look at what happens when we're upgrading a worker node, where we actually take the worker node temporarily offline by performing what's known as a drain on the worker node. But we'll get to that when we actually get to the point of performing the upgrade on the worker node. So at this point, we have a running cluster here. If we do kubectl get node, we have our 3 nodes here, the 1 master and the 2 workers. And then if we do kubectl get pods, you can see that we've got these 4 pods that are running across the 2 worker nodes. So at this point, we can go ahead and initialize our upgrade process by starting with our master node. I hope this has been informative for you, and I'd like to thank you for viewing.